Scientists have made an incredible find at the very center of these enigmatic cosmic creatures. They have unearthed something amazing and terrifying inside a black hole, challenging everything we thought we knew about these wonders of the cosmos. Get ready, because we are about to reveal the fascinating secrets hidden in the mysterious core of a black hole. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it so it reaches more people, and turn on the notification bell. Black holes are a fascinating phenomenon, as postulated by the brilliant scientist Albert Einstein in his theory of general relativity. According to this theory, the gravity on the surface of a black hole is so intense that even light cannot escape it. Gravity does not behave like a conventional force, such as magnetism or pull and push, but is the result of the curvature of space and time. That is, gravity arises from how objects with mass and energy warp or bend the fabric of space and time. The curved space and time mentioned above refers to the gravitational field. The more energetic an object is, the stronger its gravitational field, and the more pronounced the deformation it causes. Following this theory, let's talk about black holes, which are one of the most extreme objects in the universe. They have an unimaginable amount of mass and energy concentrated in a tiny space. Because of their great mass, the gravitational field of a black hole becomes very intense, uncovering a deep warp in the fabric of space and time. This is where things become truly extraordinary. The gravitational pull near a black hole is so incredibly strong that it creates what is known as an event horizon. The event horizon is not a physical barrier, but rather a region where space gradually bends. It is an invisible boundary or point of no return. Once something, such as an unfortunate spacecraft or even light, crosses this boundary, it can never escape the clutches of the black hole. The event horizon forms an invisible force field that holds everything within it, including light, which is normally considered the fastest entity in the universe. To highlight the extraordinariness of the situation, imagine that you are turning on a flashlight. The light rays that emit travel at an astonishing speed of approximately 300,000 kilometers per second. However, if you were to somehow find yourself inside a black hole, the speed required to escape its pull would be even faster than the speed of light. This is completely impossible according to our current understanding of physics. At the core of a black hole, we find that it is known as the singularity. It is the place where all the mass and energy of the black hole, no matter how intensely large, is squashed and compressed into an infinitesimally small dense point at the center. The singularity is like a gigantic cosmic entity with extraordinary gravitational force and curvature. In fact, the singularity has infinite curvature and gravity, which is fascinating. Our understanding of physics begins to fall apart when we try to make sense of what is going on in the singularity. We simply don't know what is going on there. It is as if the laws that govern our universe take a break or go absent, leaving us perplexed and bewildered. Knowledge is exploring this enigmatic territory in the hope of uncovering the secrets hidden in the heart of black holes. To understand how black holes formed and what happens inside them, it is necessary to go back to the life cycle of a massive star. These massive stars are true cosmic powerhouses fueled by the incredible nuclear fusion reactions that take place in their cores. The sun's energy source comes from the fusion of hydrogen and helium. During this process, two hydrogen atoms combine in a collision and form a helium atom. As long as the star has enough hydrogen to carry out the fusion, it can maintain its brightness. However, stars have a voracious appetite and want to keep the fusion party going. When the hydrogen in the core is depleted, stars get creative and start fusing heavy elements, such as helium, carbon, and oxygen. Each fusion reaction with heavier elements produces less energy than previous one. To compensate for this decrease in energy, the star has to work harder to burn faster, increasing heat to maintain its delicate balance. However, there comes a critical point at which the star can no longer fuse any more elements. At that extraordinary moment, the star collapses under its own weight as a magnificent implosion. It is at that instant a black hole is born, and the collapsed core forms the heart of a black hole known as a singularity. For the first time, scientists have directed their state-of-the-art telescopes into the interior of a supermassive black hole located in the core of a galaxy at a staggering 800 million light-years. Black holes are known for their insatiable appetite, devouring anything that comes too close to them. In this case, the black hole's voracious cosmic feast was truly extraordinary. When the matter fell into the black hole, it was heated to extreme temperatures, reaching millions of degrees. The scorching gas created a glowing corona around the black hole, forming an intense cosmic halo. The resulting X-flares, like cosmic fireworks generated by the superheated gas, did not disappear into the abyss of the black hole. In fact, it experienced a peculiar cosmic bounce. These flares, reflected from the gas behind the black hole, defied the laws of physics as they confronted the magnetic and gravitational fields of the black hole. And guess what? They survived the immense gravity and magnetic fields. The immense gravity and magnetic fields of the black hole bent the X-ray flares, giving them a curving path that eventually reached our telescopes. This amazing discovery represents the first direct observation of light coming from inside a black hole. And guess who gets another confirmation of this theory? Albert Einstein and his revolutionary theory of general relativity, which predicted that light could be bent by gravity. This observation fulfills Einstein's prophecy, reaffirming the brilliance of his ideas. But how did this revolutionary discovery come about? The story centers on two impressive space telescopes, the XMM Newton, operated by the European Space Agency, the James Webb Telescope, and NuSTAR, operated by NASA. These telescopes were focused on a supermassive black hole and witnessed quite a show over several days. They observed fascinating X-ray flares emitted by the scorching hot corona surrounding the black hole. However, things took an intriguing turn when the researchers dug deeper into the data and noticed something peculiar. Some of the flares had different colors and arrived later than others. This raised another question. Why did some arrive later than the others and have different colors? Eventually, it was discovered that these X-ray codes came from inside the black hole itself, which contained this surprising observation. The researchers set to work and immersed themselves in an exhaustive analysis, using cosmic numbers in their calculations. The pieces of the cosmic puzzles fit together perfectly, revealing something extraordinary. They were witnessing a phenomenon known as light echoes. As we well know, black holes possess extremely powerful gravitational force that even light cannot escape. However, in the vicinity of a black hole, one often finds a spinning disk of material, such as gas or dust, concentrated by its immense gravity. This material heats up as it spirals towards the black hole, emitting X-rays and other types of radiation, creating a luminous ring known as a corona.
Imposing masses of enigma float in vast space, a subject that has always left us with unanswered questions. However, the time has finally come for a radical change. The James Webb Telescope shows us what lies inside these towering masses of enigma, also known as black holes. Join us to the far reaches of this black hole to learn more about what's inside. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel, be sure to like this video, share it so it reaches more people, and turn on the notification bell. It all started in 1916 with Albert Einstein's general theory of relativity, who was the first to predict the existence of these entities. Although the term black hole was officially coined 50 years later, some scientists already believed in Einstein's theory, while others dismissed it. It was in the late 1960s, when researchers were studying the constellation Cygnus X1, that they noticed something amazing. A strange, bright blue star was emitting X-rays, revealing that it was no ordinary star. This blue star was orbiting around something giant and dark. Upon further investigation, it was discovered that the X-rays were not moving on their own, but were attracted to the mysterious entity that the star was orbiting. Whatever was at the center of that orbit turned out to be a powerful force that consumed everything around it. At that point, science gained official evidence that black holes were a reality, but little did they know that things were about to get even more extraordinary. The initial discovery of Cygnus X1 turned into a series of additional discoveries before it was discovered that there could be approximately 100 million black holes in our Milky Way galaxy alone. However, due to their incredible difficulty to be detected, we still do not have an accurate and precise number. According to current estimates, this number is in the several millions, which makes them even more important objects of study. According to most physicists around the world, A black hole is an entity where anything that enters it is compressed astronomically until it becomes a singularity. To simplify it into simpler words, they have explained that due to the way black holes work, if someone were to fall into one, they would stretch like spaghetti, slowly dying in this form before reaching the final spaghetti form. And this is one of the scariest parts of the research done on black holes, and is also what makes everyone want to know all the details. Although the closest black hole to Earth is 1,500 light-years away, this information still raises the question of whether black holes can actually swallow the Earth whole. In 2021, scientists managed to publish the first clear photograph of a black hole, specifically the black hole M87. The black hole was photographed for several nights in a row, and with each image, researchers collected more and more evidence about it, revealing the existence of 3 fundamental layers in its structure. That's right, a black hole is not just a lone hole in the void. To delve into the depths of its mystery, you need to understand the first 2 layers. Let's break it down. First, there is the outer event horizon, a boundary that surrounds the mouth of every black hole. Once something reaches this point of the black hole, it cannot escape and is either trapped there or is pulled deeper on its journey to the singularity. The singularity, on the other hand, is the central core of the black hole, where gravity is so intense and constant that literally nothing can get out of there. To escape, something will have to travel at a speed much faster than the speed of light, which has so far proven impossible. It is important to note that gravity on Earth works differently. If it were similar to black hole gravity, we would not be able to survive the way we do once we have crossed the event horizon. We have in front of us black holes, the great ultimate enigma, the singularity. This is the point at which most of the mass of the black hole is concentrated, where everything is compressed to become practically nothing. Physics as we know it stops working inside black holes, both on Earth and in most of the space we have explored. It is absolute chaos, and the worst part is that each black hole is unique, with a different gravitational force and attraction. You could gain complete knowledge about one black hole, only to have to start from scratch when you explore another. It's like a never-ending puzzle. The problem is that scientists cannot study black holes in the same way they study stars or other planets. They can't just look at the radiation they emit, along with the dust and gas that surrounds them. They cannot send something like the Voyager probe into the interior of a black hole, since, as we have previously established, it would be crushed in when it reached the singularity. Simply put, our only option is to study these massively powerful phenomena in space in 2 dimensions, since we cannot get close to them. The fact is that so far, we have not been able to get inside the singularity to really find out what it is, because as we have established, it is practically impossible to travel faster than the speed of light. However, this does not mean that the scientists who have been studying these giant masses of mystery do not have their own theories. They have numerous theories about what could be inside a black hole other than the singularity. One of the most plausible theories is that black holes are not simply masses of nothingness, but that beyond the event horizons and the beginning of the singularity, there could be something else. This theory suggests that black holes could be like doors, but we don't mean a door leading to a common place. We're talking about the possibility of traveling between galaxies and universes through them. Another interesting theory posits that black holes could be a glitch in the Matrix, using this metaphorical reference. If we could develop technology capable of faster-than-light travel, we could open our way through one of these black holes and explore what lies on the other side. However, these theories are still in the realm of speculation, and scientific exploration continues in search of more concrete answers. It is possible that the singularity is not simply a void, but a wormhole leading to another galaxy. It would be a shortcut in interstellar travel, something we never thought possible. This idea raises the possibility that we might not be limited to exploring only the planets in our own solar system. We could look for ways to traverse these black holes and reach the galaxies they take us to. If this turns out to be true, it would mean that limitations once assumed to be insurmountable might not be as impossible as previously thought. At the opposite end of the spectrum of theories, we find one that rejects the existence of black holes altogether. Tokyo-based scientist Enrico Rinaldi and his team have been trying to make sense of these phenomena, despite how strange they seem. They've come up with a simple theory that explains all of this madness. According to this theory, black holes are simply holograms, Now, holograms as we know them are holographic images created through technology. But here, not all holograms are the same. Any visual discrepancy or illusion can be considered a hologram as well. And when we're talking about the vast abyss of space, anything is possible.
The Big Bang Theory represents the pinnacle of cosmic explanation, outlining our origins. However, the James Webb Space Telescope has discovered something that it completely changes this notion. Neil deGrasse Tyson points out that this telescope has observed black holes from an earlier universe, raising the possibility of rewriting our cosmic understanding. This finding raises questions. To what extent will our cosmic conceptions be altered? The JWST finding seemed incoherent to astronomers. Could they have been wrong about the Big Bang, or could there have been errors in the measurements? This uncertainty leads us to probe further. The James Webb has detected extremely old galaxies, marking one of the most remarkable scientific achievements. The formulation of the hot Big Bang theory has been one of these achievements, proposing that our present universe arose from a hotter, denser, and more uniform state. This theory emerged as a solid alternative to the initial explanations for the expansion of the universe. In the 1960s, the discovery of the cosmic microwave background radiation, recognized as a primordial fireball, gave significant impetus to this theory. For more than 50 years, the Big Bang has been the dominant theory to explain our cosmic origins, supported by the inflammatory period that preceded it and defined subsequent events. However, both cosmic inflation and the Big Bang have faced persistent questioning by astronomers and astrophysicists. The discovery of massive galaxies in the early stages of the universe by this telescope raises the possibility of reconsidering our understanding of the cosmos. These findings challenge current astronomical models and offer unprecedented insights into the universe in its first few 100 million years after the Big Bang. The James Webb Space Telescope, despite having a short history of less than 2 years, has already provided extraordinary insights into the universe in its early stages after its formation. Its revelation of large stellar galaxies using infrared tools has been remarkable. 6 giant galaxies have been identified from the early stages of the universe, which, if their magnitude is confirmed, could transform our understanding of galaxy formation. These discoveries, published in the journal Nature, are based on data collected by the James Webb Space Telescope. The existence of these galaxies at such an early period, between 500 and 700 million years after the Big Bang, is perplexing, as it contrasts with the current understanding of the formation of the universe, which is approximately 13.5 billion years from its origin, relative to its current age. These findings challenge established perception of galaxy evolution. After the colossal event that gave rise to our universe, the amount of matter in the first galaxies could be 3 times larger than expected, reducing the need for highly efficient star formation. However, current models suggest an age for the universe of about 13 billion years, in contrast to the 13.7 billion years obtained by other measurements. This discrepancy raises significant uncertainties. One possible explanation centers on the possibility that astronomers are incorrectly assigning some of the observed light from galaxies to stars. It is suggested that this light could originate from gas disks around massive objects, one of the most plausible scenarios. Despite having cited only a few of these galaxies, astronomers warn the possibility that their presence in a very small fraction of the sky is not representative. This observed strain raises a crucial question: are these galaxies really as distant as they are believed to be? On the other hand, astronomers at the University of Arizona point out that nearby, lower mass galaxies may simulate the appearance of distant massive galaxies. Definitive conclusions await further measurements. Most crucial at this time is the absence of detailed spectroscopic data from these galaxies, which could reveal their true distance and potentially allow detection of black hole signals. In a short time, perhaps a few years or even less, the gravity of the situation will become apparent. While we store this data, we explore the theories proposed by astronomers to explain this phenomenon. Some of them speculate that an unknown mechanism may be at work at this juncture. One hypothesis suggests that the existence of massive black holes in the early universe might offer a clue. According to astronomers, this assumption would help to understand why massive galaxies show up in telescopes. However, the dilemma arises of explaining the appearance of numerous black holes in that ancient cosmos. There is a controversial theory advanced by a Nobel laureate that contradicts the prevailing theory about the origins of the universe some 14 billion years ago. This idea holds that everything that exists or will exist will be contained in a dense infinitesimal singularity that exploded, giving rise to everything in our observable universe. This is an elementary simplification of the Big Bang, although for several physicists, the duration of 13.7 billion years seems insufficient for the formation of complex structures, such as superclusters. The scientist proposes an unconventional idea of the Big Bang. Mr. Roger Penrose, a Nobel laureate in physics known for his work on black holes and mathematical methods, suggests that the Big Bang was not the beginning but rather a singular episode in a recurring cycle called wreck. He imagines multiple Big Bangs or eons that will occur throughout the history of the universe, each marking a new phase. Penrose, awarded by the Nobel Prize in 2020 for advancing mathematical techniques that extended over Einstein's theory of relativity, suggests that the universe will continue to expand until all matter disintegrates, triggering another Big Bang and giving rise to a new universe. He stresses that something predates the Big Bang and anticipates something to come in the future. In his theory, called conformal cyclic cosmology, challenges the traditional Big Bang narrative. Penrose points to the discovery of 6 anomalous points in the sky, named Hawking points after Stephen Hawking, that indicate potential locations of massive black holes. Despite the difficulty of observing them at the current age of the universe of 13.77 billion years, these points imply the existence of such black holes. Penrose's theory suggests that our universe is neither the first nor the last, but part of a continuous cycle that originates from a highly ordered mass that evolves into the intricate cosmos we know. He criticizes the prevailing Big Bang model, arguing that it lacks an explanation for the highly ordered, low-entropy state at the birth of the universe, unless events began before the Big Bang. Their 2020 paper, published in Monthly Notices of the Royal Astronomical Society, presents evidence for unusual circular spots in the cosmic microwave background, the CMB, with elevated temperatures. These data, analyzed from the Planck satellite and validated by simulations, suggests remnants of evaporating black holes from past eons. Penrose's theory of cyclic cosmology holds that the universe will go through periods of collapse and expansion, eventually culminating in another Big Bang. Critics debate the plausibility of this hypothesis because of the difficulties in reconciling the size of the universe over eons and the implications for particle mass loss. While contested, Penrose's theory challenges conventional cosmological perspectives and offers significant implications if proven accurate. It challenges traditional views and highlights the complexity of reconciling different sizes of universes over cycles. Whether his theory constitutes a credible alternative to the Big Bang remains a subject of ongoing debate and scrutiny within the cosmological community. A physicist at Oxford University challenged the conventional Big Bang model based on evidence derived from cosmic radiation, which formed when the universe was only 300,000 years old. This view challenges the unusual notion of the Big Bang and raises questions about how large-scale structures were generated in such a short time span. If you liked the video, we invite you to show your support by leaving a like, subscribing, and activating the notification bell, as this motivates us to continue creating content. Thank you so much for watching, and I'll see you in the next one.